Welcome back, C++ code lovers. At this point, we've done quite a lot of programming. We've seen control structures, we've seen loops, arrays, even some introduction to object-oriented programming. And I hope you've gotten the gist of programming in this crash course we've had. Hope, hope we've helped. I'm not sure I have, but I'm hoping for the best. Today we're going to do something quite not so different from what we did last time. We're going to continue with arrays. So that we're going to continue with two-dimensional arrays. So we've talked about loops, we've talked about nested loops. Now we're going to talk about arrays. We're going to continue on the discussion with arrays, and we're going to talk about 2D arrays. I'm not sure that writes quite well. Okay, it's lagging, I'm not sure for what reason, but 2D arrays. So think of them to be some kind of table with rows and columns. Okay, this board is really punishing me, but you don't really have to worry much about that. Won't be here long anyways on the board. So think of the arrays as a table with rows and columns. So let me say these are the columns. And these are the rows. And of course, every table should have rows and columns, right? One way or the other has rows and columns. So how you declare arrays is almost the same as how you declare these two-dimensional arrays. Is almost the same as how you declare arrays, one-dimensional arrays. Just mention the name and don't forget your square brackets, right? Your square brackets or square brackets, whatever we'd like to call them anyways. The indexing is, think of them as a combination of 1D arrays. So 1D arrays. Okay, so just think of them as a combination of 1D arrays. Many of them, so imagine this is a one-dimensional array, that's a one-dimensional array, that's a one-dimensional array, and they keep on going like that. So when you're indexing them, you reference them by the row number and the column number. So for example, this is row number 0 and column number 0. I mean, the index still starts from 0, right? This here will be row number 1, 2, 3. We're looking at this entry in here, and column number 3. So you'd say array, row number 3, and you want the entry at column number 3 of row number 3. Oh no, not really 3. I was counting from 1, so that would be 2. Because arrays, you have to start counting from 0. So 2, 2. Okay, so that's how you reference these things, that's how you index them. And that's the idea behind arrays. You have to use two of those square brackets, right? And then after this, after we understand what these arrays are, we're going to talk about Pascal's triangle. Now, I've promised to talk about Pascal's triangle, and we're just going to talk about Pascal's triangle in more detail. So, of course, it was covered by the Chinese in 12,000 BC. Is it 12,000? 1200, and that's better to say it in is 1200. Yeah, 1200 BC, somewhere there, 1293, and later on Blaise Pascal rediscovered it, and Isaac Newton, when he was 23 years old, he was developing his binomial theorem, and he discovered that the coefficients actually the terms in Pascal's triangle. So you can use either Newton's theorem, binomial theorem, to get the coefficients in Pascal's triangle, or better still, we can use just the simple practice of Pascal's triangle. So it's really a basic one. If you start at 1, you have 1, 1, just understanding it. If you start at 1, you have 1, 1. This entry is 1. This entry is 1 plus 1. So I'm going to write that in the middle. That's going to be 2, 1. That's going to be 1, 1 plus 1, which is 3. This plus 5, which is 3, and 1. The circle continues. So what I want you to notice that it's the sum of this term is the sum of this term and that term. Okay, so if you were to write them nicely for a programming purpose, it would be a triangle such as this one. 1, 1, 1. They're indexing them, right? And then 1, 2, 1, 3, 3, 1. Okay, so as you can see that 2 and 3 are in the same column. 1, these are in the same column. Those in the same column together with this one. Right, those also in the same column, and these are in the same column. So how do you get an entry in the next row? It's the sum of the entry in the previous row, in the previous column, plus the one directly above that column. Right, that's how you get 3. So the sum of those two. So I'm just going to go over to dev. You can use Visual Studio Code, whichever one seems better to you. I'm going to use dev plus plus, and let's see how that goes. Alright, I'm just loading up dev. There goes, it's loaded up. I'm going to open a new file. I'm going to make a new file rather. I'll just save it as I'll call it Pascal. That's CCT. Okay. Now we've understood the notion of arrays, multi-dimensional arrays. Let's try to write some examples. So I'll say include IOStream. Now basically they work the same as 1D arrays. So I'm going to use them to make Pascal's triangle. There's another method you can use to make Pascal's triangle, but I like this one better. It's one I used when I was first learning programming, so yeah, I was so happy after I made the code. But let's say you want to make a multi-dimensional array. Maybe it's an array, it's a table. What can we store in the table? Let's say I just want to store numbers. Okay, let's make two types of tables. Let's say I just want to store numbers. So let's say it's an integer array. I'm going to create numbers, and you can say that and that. Okay, but then that's going to give you an error when you run it, because you have to give it at least the dimension. So maybe tell it it's a 5 by 5 array or 5 by 4. Okay. Then I will make a for loop. Now to access these elements, you have to use a nested for loop. Why is that so? Let's go back to the board. One loop will be controlling how you're running along the row and in each column. And the other one will be controlling how you're moving from one row to another. So from one row to the other, how you're moving from one row to the other. So one row is how you're moving from this row to that row to that row and that row, like that, right? That's being controlled by one loop. The other loop is controlling how you're moving in between the columns from one column to another in the row, and from one column to the next, one column to the next. So whenever you want to traverse a multi-dimensional array, you have to use a nested for loop. You can still use a nested while loop, so the nested for loop is more preferred because you know how many iterations they're going to do it depending on the dimensions. So I'm going to say int I is equal to 0, I is less than, let's say I'm going to have 5 rows, and then I plus plus for int j is equal to 0, j is less than 4, j plus plus, and I'm just going to initialize all the entries in the array. We initialize all the entries in this array. So at index I comma j, I'm going to initialize them all to, let me say 2, I don't know, 1, 0, whichever one you want. Cool. And then to print them out, you have to use another loop. You can still use the same I and j because they're different in every loop. J is equal to 0, j is less than 4, and j plus plus. Then I'll just say cout. I want to print out my entry at numbers I comma j. You just don't forget to leave a space. And of course, after this, you want to print an empty line. Okay, that's better. We're just going to compile and run that. Okay, there it goes. You have a table of 111. Okay, yeah, and it's 4 rows and 5 columns. Oh, sorry, 5 columns and 4 rows. What am I saying? 5 rows. One, two, three, four, five, and 4 columns. Forgive me for that. Okay, cool. You can still say each element. You can still say out. You want elemented numbers, maybe 2, 1. Right. That's going to work. Compiler and okay, I have if student B1 is because they're all one. Right, so there goes. There you have it. You have multi-dimensional arrays. You can store anything. So imagine the entries to be maybe each student's grades in a certain row. Those can be a student's grades, and then you can make a table of student grades. So you can really store anything. It has to be the same data type though. Don't forget it has to be the same data type. So we've made this work quite right. Looks nice, but not so impressive. Let's try to make a multiplication table with multi-dimensional arrays. Let's see if that's going to work. So let's make a multiplication table, and then after the multiplication table, we'll try to make Pascal's triangle. Okay, so let's make the multiplication table. I'm sure we know what it looks like. I'm going to have entries from 1 to n. N, to make it interesting, let's make n user defined. So I'm going to have entries from 1 to n this way and this way from 1 to n, and then inside the board. Okay, so this way I'm going to have entries from 1 to n. This way I'm going to have entries from 1 to n, and inside there will be the multiplication. So here that will be something like a 1, maybe a 2, maybe a 3, maybe a 4, and here maybe a 1, 2. No, okay, let's keep it like that. Maybe a 3 and a 4 and 5, and keeps on going like that. It's most preferred to make it a square and n by n, but then it's up to you what you prefer anyways. So I'm just going to erase that. Okay, I can make 1, 2, that's going to be a bit boring. So I think we should make the first entry there is 0. We can still make it a 1, and then I'll make this a 1, 2, 3, 4, 5. That's more preferred. 3, 4. So this index is 1 times 1, this is 1 times 2, but really it's just this row times this column, and then gives me the indexes there and the values. Let's try to make a multiplication table with simple C++ code. So here goes. Now we said we're going to make it n user defined. So I'm going to make a variable. I'm going to create int n. Let me just say num, and we will ask you to see out how many rows do you want it's able to have. Right, we're asking how many rows do you would like the table to have, and we just see out enter num. Okay, and then we make an array of n by n by num. Right now here we want to make every value in the first, that's going to be the first column, that's going to be the first row. Okay, and then we want to make it equal to 1, not really equal to 1. So say when this is less than num, and when this is less than num. Okay, I want to make this equal to j, and also my index is j comma or 0 comma I. and make this equal to I. Now I can just use the one for loop because I'm going to be doing redundant calculations. So I'm just going to say numbers at 0, I. That's the first row. That's going to be I, and then numbers at 0,